Hey guys, so hopefully with that Desmos activity that you guys went through on the first derivative test, you were able to figure out what the whole point of that was. And we're going to talk about today how to find whether or not a function is increasing or decreasing over a specific interval algebraically. Okay, and also find those points at which the function changes from one to the other, going from increasing to decreasing or decreasing to increasing, or it's just a transition point from increasing to increasing or decreasing to decreasing. All right, so we're going to go through the process of finding those things algebraically. It's easy enough to see it from a graph, but how do you do it when when you're given a function and not the graph to go along with that function? Okay, so just a reminder of what we did last week. The extreme value theorem, we talked about finding absolute max and absolute min. All right, and finding the critical numbers. For finding critical numbers, then looking at the endpoints, plugging both the critical numbers that we found and the endpoints into the original function to see what the absolute max and the absolute min were. Okay, so we did that last week. You kind of went through some exercises on that last week. The least being the minimum, the greatest being the maximum. What we're going to focus on today is the critical number part of all that. All right, because the critical number part is what's going to get us the locations at which we are transitioning from increasing to decreasing or vice versa. Okay, and those points at which we're going to have a relative max or a relative min. Okay, and they're the key points that we need. Okay, to kind of understand what's happening on our graph. Okay, and at those relative maxes and mins are when you are transitioning from one of those increasing to decreasing or the other one decreasing to increasing. Okay, so let's find those algebraically, and then kind of figure out what our function looks like and what's happening on our function when we do find those things. All right, so what is a critical number? Because that's the important thing we're going to need to find. So there's two locations at which critical number can occur. One of them is where you cannot differentiate. All right, so you're seeing in that cusp there. So at a cusp, we know that it does not exist there because you would have a vertical tangent line there, which gives you an undefined slope, and therefore we cannot differentiate there. Okay, and that is a critical number location. But the one that we're going to see more often than not is this location here, where you are given a horizontal tangent line, which we know has a slope, also known in calculus terms as a derivative, that is equal to 0. Okay, and you can see from that point here, especially in this function, you're going from increasing to decreasing. Okay, it happens at that location. That's where it transitions from one to the other. All right, so moving on. Okay, as you see in this function here, the theorem says that if f has a relative max or relative min or max at a point, then that point, okay, is a critical number. Okay, so those critical numbers are found. All right, we find them by doing our derivative. So we would take, I'm going to go through this quick. I'll do more in-depth examples later. We take that function, we find its derivative. All right, and then we know that those relative maxes and mins have horizontal tangent lines that are equal to 0. Therefore, we can set the slope, which is the derivative, equal to 0 there and solve for those locations. What you'll notice is to solve this, I'll need to factor. And when I do that, look at the two x locations at which I have critical values and therefore a relative min or a relative max, where x is equal to 0, there it is there, and where x is equal to 2, and there it is there. All right, and then the y component of that can be found just by plugging in that x value back into the original function, okay, and getting the y part of that coordinate. Therefore, we now have two locations that we just found where we know it's transitioning from one thing to the other. It's a transition point, in this case from increasing to decreasing, and in this case from decreasing to increasing. We'll talk more about that on the next couple slides. All right, so definitions of increasing and decreasing. Just looking at this slide, basically what you're going to want to do is just look at your graph moving from left to right like you're reading a book. All right, and what's happening as you move from left to right on this graph? You move from smaller x values to larger x values. Well, in this case, you see that the y is decreasing as we do that. So as we move to the right there, okay, it's decreasing. And hopefully from the Desmos activity yesterday, you figured out that as we're decreasing, you're noticing that the derivative at those points is less than 0. It is a negative number. So negative numbers there, all right, give us decreasing graph, okay, as we move from left to right. If it's equal to 0, it's a constant location, you see there, all right, as it would be indicated there. And then as we're moving from left to right, when you get that derivative that's greater than 0, positive number, it's going to be increasing. And we see as we are moving and our x values are increasing, our y values are also getting larger as we move from left to right. Okay, so looking at the graph and figuring this out is simple enough. Okay, we can tell that here I'm going to have a location that is transitioning from one to the other. Okay, but what am I transitioning from? Okay, again, I'm looking from left to right. In this case, the function is decreasing as I move from left to right. And then as I stop here, my stopping point where I would have a horizontal tangent line, therefore a derivative that's equal to 0. Okay, and then I go and I switch over to an increasing part of the function. Okay. So what would we say for that as far as when asked what are the intervals where it's increasing and decreasing? All right, so f of x is increasing from, that's x equals 1, it looks like. All right, so from 1, and then it goes on forever. So it's going on to infinity. All right, and then f of x is decreasing. All right, so if that's, again, we should have some arrows there showing that this is going on forever. This is negative infinity to 1. Okay, notice I didn't include in that interval the infinity or the 1 because infinity obviously can't be included because it's not a number, it's just going on forever. Same thing with the negative infinity, and also not at the 1 either because 1 is not included. 1 is the transition point. At that instantaneous spot at 1, it's not increasing or decreasing. Remember, it's, you got a 0 point there, right? It's a transition point from one to the other. Okay, so that's how we would show the interval. If you remember from probably your pre-calc days of doing intervals, that's what they look like. The increasing part is going from 1 to infinity. The decreasing part as we move from left to right is negative infinity to 1. All right, in this function, a little bit more going on. All right, in this case, we would have an asymptote there at negative 1. All right, that's separating those two components of that graph. But what you'll see is we have increasing here till we get to this point, okay, about this point here, which is about -2, and then it transitions to decreasing, okay? And we jump to the other side, and it starts off as we go from left to right, decreasing after that asymptote there. You get to 0 here, and then the function transitions to increasing, okay? So there's a couple intervals for each one that we would have to identify. So let's do increasing first, okay? The two increasing functions, the one is, in this case, it's negative infinity to that -2 location. Again, neither one of them is inclusive because, all right, can't include them because -2 is a transition point. It's not doing either. All right, and negative infinity we can't include. All right, and then the other one would be 0 to positive infinity. Okay, f of x decreasing. All right, decreasing from that -2 to the asymptote there, right, and it just keeps going down. So this is -2 to -1, okay, neither one's inclusive there. And then in this case, decreasing from -1, oh, sorry, -1 to 0, okay? And again, neither one of those numbers being inclusive, okay, in the interval. So that's how we would identify it just looking at the actual function itself, graphed. Okay, simple enough to see where the transition points are. Okay, those relative maxes and relative mins, where are they located? And then seeing what's happening as I go from left to right on the graph and approach that relative max or that relative min, either increasing or decreasing, and then it changes at those critical values, which are the relative maxes and mins. Slide here should really just serve as a summary of what you kind of went through yesterday on the Desmos assignment, and that is basically that to test for increasing and decreasing functions, you're noticing that derivatives, when you get the derivative, all right, and that value is greater than 0 in that location, then the function is increasing. So positive slopes, positive derivatives there are giving you a component of the function, all right, a part of the function, an interval of the function that is increasing. When they're negative, negative means decreasing, okay? So negative slopes, negative derivatives there, all right, a decreasing part of the function. And then when it's equal to 0, it is a constant location, okay? And a lot of times that 0 part is just the transition between the increasing and the decreasing, okay? The last thing to talk about is how to know where your relative maxes and where your relative mins occur. Well, first off, they're always going to occur at those critical values, okay? So you can also tell what's happening, whether it's a relative min or a relative max, or neither, honestly, from the values that you are testing and getting on either side of that critical value that you've already found. And when we go through an example, it'll make a little bit more sense. But for example, if you're getting you have a decreasing part of the function, so you're getting negative slopes over here, all right, and then on the other side of that critical value, you are getting positive ones. That means you are decreasing and then transitioning to increasing. That would make that a relative minimum, as you can see there. All right, relative maximums occur when, okay, so on the left-hand side of the values that I'm testing over here, I'm getting positive slopes, okay, positive derivatives here. And then I get to my critical value point, which I've already found. And then on the other side of that, I'm getting negatives. So as you can see there, increasing to decreasing makes that a relative maximum, okay? And then there's going to be some cases that you find where it's transitioning. It's a transition point, but it's transitioning from increasing to increasing or decreasing to decreasing. So I have increasing points. I still hit a critical value there where I have a slope that's equal to 0, but then on the other side of that critical value, it increases again. All right, so if that's the case, you don't have a relative max or a relative min, but you still have a critical value. It's still a point, all right, at which your slope is equal to 0. Okay, and the same thing happens over here, decreasing, hit the critical value, slope equal to 0, derivative equal to 0 there, and then it transitions back again to decreasing slopes, decreasing derivatives there. So then you also have it's transitioning, sorry, from decreasing to decreasing. There is no relative max or relative min there. Okay, but again, that C point still is recognized as a critical value, just don't have a relative max or min. In our next video, we are going to go through these two examples, all right, and in those examples, we'll identify the intervals when it's increasing and decreasing algebraically, all right, and then because we can do that, all right, or the only way we're able to do that is by identifying critical values, which remember we said are where the relative maxes and mins occur. I'll show you where to find those, all right, and then we'll use those points to help us figure out which part of this function is increasing, which part of this function is decreasing, okay? So we'll get into that in the next video.